No. That's what happens when I hit the wrong button. How is everyone doing? I was looking down here at the button and I was like, hey, which button? And then I hit that button and I was like, no, the intro button. How is everyone doing? And I see myself appear on screen. I'll have to look at that later. But how is everyone doing? We should be live streaming right now. You just saw the intro for the project. Good to see you here, Grace. Good to see you here, Candy. I was like, that's not the intro. That's me on the screen. I look up and I was like, nope. Hey, Leslie, how you doing? Good to see you, Chase. Intro of the project. Everything's fine. So everyone knows who came over here from Alyssa's stream. Alyssa was doing some work right there. Let's put up the code. I was getting everything going. This is a very, very good Kahoot right here. Where's my UT Marvel? UT Marvel, where you at? There we go. Kahoot is up. Good to see you here, Autumn. Good cartoon, though. Thank you, Maya. I can switch my openings. You can't really see it right here, but I've got all my openings set that I can go between them. And so here I can show you on the screen right here. Here's the Stream Deck. So you can see the Stream Deck, and I clicked on the Everything is Fine opening. And so I clicked, because I can go to like the Crazy opening or the Crash opening or the Crab Rave opening. Hey, let's just see that Crab Rave opening while we're going right here. So then I clicked the button over here for the opening. It's got Rick and Morty. So I meant to click that one, but I clicked the one next to it, which is my space animation right here. Here's the Crab Rave. So all these right here. Yep, Clarissa, you got it. We're definitely doing some Canvas content relevant questions. Let me turn up the audio right here. We don't even have our disco music going. What are we doing, everyone? What is going on right here? Now we got the disco music going. It's Sunday night. It is Sunday. Getting everything going. I should have another module ready for the asynchronous class coming here soon. Should be out later tonight, getting it finalized. I've been working on these all semester. Hopefully you're liking it. Anyone here from the asynchronous class? What do you think of the modules so far? Pretty easy to follow along, review, and go over the material. Hopefully it's more of a interactive type of experience than just reading a book or reading slides. You get to click on stuff, you get to answer questions, and it's not just pre-written slides, all this stuff right here. I'm actually working on it every week. Thank you so much, Autumn. I'm glad you like it. Glad, Maggie. Glad you like it, Renee, too. I really like doing the tacos and burgers stuff. I was just thinking about tacos and burgers the whole time. I'm just like tacos, burgers. That's good to hear, Leslie. And do people think, hopefully people are learning through it. Grades are looking pretty good. So I'm just hoping the modules are helping, and I'm working on the module right now for this week. Well, not right now, but I was working on it earlier today. Thank you so much, Leslie. Yeah, and I try to put in as many. I want some critiques of this at the end of the semester. If more examples would help, if more interactive graphics would help, like what people thought was the best, if the note cards help, the flashcards help. Good to see you here, Maggie. Like, yeah, Samantha, that's what I like. And I hopefully add in enough interaction through them. Yep, we'll be doing some Project 2, you bet. And there's the Project 2 playlist. And I think, did anyone come from Alicia's? The note cards or flashcards are helpful. Thank you so much. I hope I put enough flashcards. Sometimes the one I did last week, I was working on like, oh God, I worked on like 6-7 hours or something. And then I usually do like a final check. And I think I'd been doing some checks like going through. And then I exported it and uploaded. And I was like, did I do a final check? And then I went through and I was like, I should have put a stop in here. Because, it's got those things that says like, you have to do this part of it. Yes, Alyssa's excellent. Thank you, Alyssa, for doing so much awesome work. Let's put on a 2-minute timer. We'll start the Kahoot in 2 minutes. This is a very important Kahoot. I can promise you that a lot of the questions in this, let's just say this Kahoot is pretty good. And we're doing first, second. You know what? Should we do a third place tonight? First, second, third, 20, 10, and 5. Who's up for that? Who's up for 20, 10, and 5? First, second, third. Make sure to come to these Kahoots. 20 for first, 10 for second, 5 for third, 5th for third. So we got some more prizes tonight. First, second, third. Any student can win. If you're 320, that's all right. You can win. Here to help review. As long as we get one 201 winner, I'm happy with that. I'll tell you what, 201 winner will at least win $10. So if for some reason all the 320s come in, they're like, we're going to win. We're going to make some money. We're going to know our statistics and make money. I'll make sure third place gets the highest 201 will always get $10. That's my promise to you. And thank you, everyone, so much. Semester's been going great. Busy semester. How much time we got on the clock here? Busy semester, but everyone's bringing that energy. That energy. And that's what is appreciated. Because I understand man, who else, can you believe it? I think it'll be 2.5 weeks and the semester's over. 2.5 weeks. And then they'll be talking about like what you're doing for the summer. You're like, man, I got summer classes. I got summer internship. I got summer job. I'm just going to take summer vacation. I got summer classes. Ah, you can't, Skylar? Oh, man. Anytime, man. It's gone by so fast. I know, craziness, right? Thank God right there. Larissa says, summer classes, it never stops. You got this, Kyle, though. Let me say the biggest important thing ever. When it comes to classes, I truly mean this. It's not about making A's. It's about learning and applying what you know. And I know that just sounds like everyone tells you that. It's not about making A's. Making good grades is important, but it's more important you are able to take what you know and apply it. Because all I hear from companies is like they want to see people utilizing these skills. If they see someone can code and they give them questions and that person's quick on their feet, hopefully our classes, especially when you take like business analytics classes or Stat Tool 1, give you tool sets to use in your major. And it's okay if you're not stats or business analytics. We want to give you a tool set you can use, and that's hopefully what this Kahoot is doing. That if someone says, hint for the starting questions, if we're going to analyze some quantitative data, what kind of tests are we going to use? So, hey, we're starting here in literally just seconds. So log on. We were at 24 or so. So jump back into this. So if someone's like, hey, we're going to analyze some quantitative data, hint for the Kahoot. What kind of tests should we do? How should we analyze this? I don't know. Starting in 5 seconds. 5-second countdown. We got winged giraffe. What is a winged giraffe? How does that even exist? Would it have like humongous wings that could actually carry it, or little tiny wings? Starting at the end of the song. Here we go. Let's Kahoot. Okay, hop into the main screen. Yay! I might vanish. UT wants to investigate the average amount spent at Walmart a semester. What test would they use? Hint, hint, hint. Oh my gosh. Why'd I put 20 seconds on this? I don't know. Be quick. We've only covered this one so far. If you keep going with class, people are like, what? Waking you up right here. I swear the other ones have more time. Yes. Okay, let's review. I forgot that one had such a short time, hence why I gave a hint on it. Why is it a t-test? And how does anyone remember that? How do you remember it's a t-test? And what did you notice right here? There's something right here, and this goes for especially what we've been covering. So what do you notice right there immediately? What are people noticing, and how does that tell you it's a t-test? Any thoughts? Thoughts on this right here? How do you know it's a t-test? It's for the mean, Lauren says. Exactly. And what is Mr. T? If you're not doing what you should be doing, what is Mr. T? Mr. T is going to be what? We're doing some tests right here. Mr. T, if you're not doing what you should be doing in life, Mr. T is going to be what? So we talk about the T distribution versus the Z distribution. And the way to remember this is the T distribution, which looks just like the normal distribution. The T distribution looks just like the normal, but the T will always have with it what? The T, which looks just like the normal, will always have with it what? Anytime you talk about a T, you should ask me, what are the this for this? You should know Mr. T is mean if you're doing drugs. Not doing what you should, Mr. T is not going to be happy with you. And so the T distribution has degrees of freedom, and the degrees of freedom tell you which T you're using. When is the T most like the normal? When is the T, like this one right here might be basically the normal. Like if I drew the normal, maybe the normal is like this right here. I guess, yeah, that'd be right. Mr. T smashes it down. Normal will be like this right here. So there's the normal right there, which stands for normally distributed with mean and sigma. When is the T like the normal? The T becomes the normal with large amounts of degrees of freedom. Great job, Dylan, right here. And Dylan, I think, yeah, Dylan's reviewing. Higher degrees of freedom equals more normal. The less degrees of freedom it has, the less normal it is. And the T and the Z are basically the same thing. So great job, everybody. Dylan's here reviewing. I think, Dylan, are you reviewing? Which is awesome. I appreciate it. I want people to be practicing this. We'll be doing these other tests later. Proportion deals with what, though? If you see proportions, the question up here must be what? This is good review for later. The question up here, if it's proportions, the question needs to be what? Which proportions was the second most answered question, but if it's proportions, this question must be dealing with what? I swear I have more time for the other ones. There won't be another 20-second one. I like certain things. How degrees... So the degrees of freedom are basically like... it's like every t-test is ice cream, and then the degrees of freedom are the flavor of ice cream. I don't like that analogy so far. I just want ice cream. You are Kirsten right there. It is categorical. So let me bring up the T with the degrees of freedom. So the degrees of freedom are based on the sample size for right now. We'll go into more detail later. But whenever you have a T distribution, right here, trying to find everyone, whenever you have a T distribution, it will have with it degrees of freedom. When there's very little degrees of freedom, the T is not normal. Does this make sense to everybody right here? When it gets more degrees of freedom, what do you see it becoming? More and more normal. And then the T score is just like the Z score. So how degrees of freedom tell you the T? So it's basically like, what T are we using? So that does that make sense there, Cody? It's like, what T are we using? This is a T with, let's say, 60 degrees of freedom. The degrees of freedom right now are n-1 for the one sample T. Just memorize n-1 for one sample T. So what would be the sample size? There's problem. Last question on this right here. What would be the sample size if these are the degrees of freedom? This problem would be one that read, we went out and sampled how many UT students? So if this was a test question right now for one sample T, it'd be like, we asked students how much they spend at Walmart a week, and we talked to how many students? 61. Because right now for a one sample T, the degrees of freedom are n-1, and this tells you which type of T you are using. There's only one type of normal curve because there's not degrees of freedom. So we don't have to worry about the sample size and the degrees of freedom, at least for which curve we're using. But if we're using the T, we have to know which T we are using, because the shape of the T will vary drastically depending on the degrees of freedom. Really great review right there, everyone. That's a review. You got to hear these things 2 or 3 times. Do not worry. And great review on the degrees of freedom. And remember, that is degrees of freedom for a one sample T. There will be different degrees of freedom for the chi-squared test of independence right here, and different degrees of freedom for the 2 sample T test. But let's see who's in the lead right here. It's Radiant Leopard, and let's slow it down a little bit. Usually there's like 900 points. Everyone was like, wait, this is so quick, I have to slow down. Hey, Brian, could you let me in the Kahoot? Yeah, join right there, Sarah. You're more than welcome to. The code is right down here. We'll pause here for just 10 seconds, but click in, join in, and we will have you in the Kahoot. And I promise everyone, there are questions very relevant to the Canvas content. So make sure to play along and check out the questions at the end. Hint, 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 as Brian would say. I am Brian. What can they use to graph the distribution of how much is spent at Walmart? This is like, but it's paused. Oh yeah, no, we're playing now again. How could they graph the distribution of how much is spent at Walmart? How could they graph the distribution of how much is spent at Walmart? Remember, this is quantitative. Oh, please tell me I select both answers. I can't remember. I was reviewing this earlier. Please pass, Brian. This is like a... Yes. What does everyone remember about these two right here? What does everyone remember about these two? What does everyone remember about those two right there? We have a famous saying with bar charts, and they are categorical. Great job, Leslie. And I don't know if I put this in the asynchronous class because it's a How I Met Your Mother thing, and I'm like, I don't know, put it in there. So I always say you can make a bar chart of your favorite pies and a pie chart of your favorite bars, a bar chart of your favorite pies and a pie chart of your favorite bars, because it's a categorical question. So when we talk about bar chart of favorite pies and pie chart of favorite bars, we're saying like you can use a bar chart to ask people what's your favorite pie, and you can use a pie chart to ask people what's your favorite bar. Oh no, that's all right. That's all right. The box, a good thing to remember after you make a bunch of jump output, what does everyone notice here with the jump output when it comes to displaying a quantitative variable? What do you notice right here? And what do you notice right here? This is a good way if you made a bunch of jump output. So you're seeing weekly hours of job, weekly hours job. Great variable name. What are you noticing right there and right there? Which this shows you the 5-number summary. This shows you more the shape center spread. This is heavily skewed. Hence, we'd use the median and IQR, hints for the project. I don't think yours is heavily skewed for the project, though. If it's not heavily skewed, mean and standard deviation for center and spread. It's exactly Madison right there. You make a bar chart for pies, pie chart for bars. And right here with quantitative data, what do we see? We see a box plot. There's the box and the plot of the box plot. Exactly, box plots and histograms go together. Great job, Lauren. And take this note, they are univariate quantitative displays of data. Everything on this screen right now is a univariate quantitative display. So the histograms and the box plots down here are univariate quantitative, unless we do like side-by-side versions of them. And the pie charts and bar charts are univariate categorical. So good review right here. Who's in the lead? Leaderboard's going crazy. Remember, $20, $10, and $5. Email me afterwards with the preferred email. If you won, Smart Piranha is going to make this happen. Let's see Smart Piranha win with the next question. Here we go. A 95% comp score goes from 70 to 78. What does this mean for the value of 67? Oh, we got some bad words on this screen. What is the word we do not want to see on this screen? So someone says, I think my test grade will be between 70 and 80. And then you say, well, do you think you'll make a 67? What would they say to you? Statistically, they might say, nah, I don't think I'm going to make a 67. And what would we say in statistical terms? We would say, I get so afraid when I point to the answer. I mean, I write the questions. So this is this is something we ended off with last week. We ended off with last week with values inside. I think we're going to start this week with it. But this goes to the idea of hypothesis testing, which we're doing right now. And we'll be starting this with next week. Don't worry, this is not on the Canvas content quiz. And I promise there's some Canvas content quiz, really relevant material coming up here soon. But think about this. Your friend says they're going to make between a 70 to 80 on the exam. They think they will. You would reject the value of 67 because it's outside the interval. So here's a big note to take. Confidence intervals can do a statistical test. If someone told you that they are 95% confident the true GPA of UT students is between 3.7 and 3.4. Let's go 3.4 to 3.7. I was like, that's really high interval. Would you believe 3.5 as a possible truth? If someone said, I did research and it looks like the true GPA of UT students is between 3.4 to 3.7, like from my research, would you believe 3.5 or not believe 3.5? Would you believe it or not believe it? If they said the interval goes from 3.4 to 3.7, what would you think of 3.5, which is my head right here? I would believe it because it's inside the interval. The interval gives you possible values, we think. Exactly, Lauren, great answer right there. Let's throw some 50 points out there. Lauren says that she would fail to reject that value. Exactly. And that is how, that is the exact statistical way of talking. So I threw some points out. The very, very statistical way of saying it is, I fail to reject that value. Now, fail to reject sounds weird to you. Just think of it as like you either reject or you do not reject. Like you either go to the mall or you do not go to the mall. So if I said, I failed to go to the mall today, you'd be like, oh, you didn't go to the mall. And I'd be like, yeah, I failed to go to the mall. It's a weird way of saying this did not happen. Like we failed to reject the null. So Lauren is 100% right, more statistical than I am. And I oftentimes say, I just did not reject, or I can continue to believe it, which means we do not reject it. You either reject it or do not reject it. So great job, everybody. Who's in the lead? I don't know. Silly bee. Silly bee. What is that? Like silly rabbit. Oh, I wish it was silly rabbit. Then it would be like tricks are for kids. That'd be so awesome. So close to the perfect name, but I'm still rooting for you and Captain Pony. Let's make this happen. Here we go with question number 4. Let's do this. Which is a proper null hypothesis? Uh-oh. We know one thing for certain. The null has the equal sign. Wait a minute, but that doesn't help us here. All of these have equal signs. The null also needs another thing. The null needs a population parameter. So that's the big hint right there. If you're stuck choosing between these, the nulls need a population parameter. It looks like this one doesn't even have anything. This is a very common error, but that doesn't even have anything there. Don't choose that one. Someone already chose it. I'm sorry. That's the wrong answer. We need a population parameter and mu. A lot of people chose this one. Why is this one wrong? A lot of people chose this one. Why is this one wrong? Why is this one? Oh, wait. Yeah, no, a lot of people chose that one. Yeah, I thought my brain went reverse for a moment. Why is that one wrong right there? Why is P hat wrong? And this is a really good review. I asked some hard questions tonight. Only 3. That's all right. Don't worry. This is a good review. Why is P wrong? That's a sample statistic. Correct. And since that's a sample statistic, what could be there, Ella? You are correct. That is a sample statistic. How would this be correct? Which will help us out for later. Remember the Greek letter, Lauren, I'm just throwing another 50 points. Lauren is giving some really awesome advice. Everyone, be watching the chat, be reading the chat right there. Remember that Greek letters go with the population and little letters tend to go with samples, especially in just P. You are correct, Ella. If this was P right here, then this would be a proper right way of writing the null hypothesis. But right now this says the null states that the sample proportion is equal to 30%. This one down here says the null states that the sample mean is equal to 100. And if this was P, it would say true proportion and it would be correct. This is the null. And one thing we need to know is the null always has the equal sign and always has a population parameter and always has a hypothesized value right here. So this says the null states, that's what that reads right there, the null states, like our starting initial hypothesis is that the true mean for whatever we are measuring is equal to 23. So we might be measuring how many push-ups people can do or something. The null states that the true mean amount of push-ups for the group we are investigating is equal to 23. This one says that the sample mean, which is something we'll know data on. And great job, everybody. This is an awesome review. Get ready for some alternative hypotheses coming up next. This is anybody's game. Do not leave. Do not leave. I wish we had 100 people playing because it'd be absolute insanity, but this is anyone's game right now. So do not worry. Who knows what's going to happen next question? Let's find out. Be quick if you know it. Take your time. I'll give some hints if you don't. Groovy Gecko, hang on to the lead there. Let's see Groovy Gecko win this. They'll have a tough time against Quick Turtle. Which is the proper alternative hypothesis? Let's see. So the alternative hypothesis is going to have less than, greater than, or does not equals to. Make sure to use your knowledge from the last question, though, to help out with this one. We reviewed some stuff in the last question, which should give you some big help. I try to join the questions together in the Kahoots, where if you're listening into our advice between them, you'll have some good hints for the next one. And do remember, we want a population parameter for the item right there. So that should eliminate two choices. And then since this is proportions, proportions have to be what? Proportions have to be what? So one, I do say that it can be any hypothesized value, like you can hypothesize any value is true, but proportions, by definition of proportions, have to be between what and what? Proportions have to be between what and what? Proportions have to be between, you got this, Sarah, no worries. 0 and 1, 0 and 1, because they're like probabilities, they're percent of times things occur. Now, once again, why is this one wrong right here? Why, we've got two competing answers where this says P hat and this says P. So why is P hat here wrong? Because every time in this position, what is always here and what should be there? It should always be a correct Madison. P hat is a sample and we're always making statements about the truth. So everything right here has to be a population parameter. So when we do this right here, exactly, Sarah, great job. And this is the practice. If you don't ace the Kahoot, don't worry. These are all questions that can appear on the test. You never know. Definitely some of these appear on the test. This is the practice we need right here so we can write the null and alternative. And if you want, just take some time to write a few nulls and alternative. We do that during class. The more time you have practicing writing them, the more you get used to seeing them. And boom, you see this right here and you're like, oh, that says the null states that the true proportion is less than 70%. You know what? Let's take a second right here and see if you can write. Let's do two nulls and see if you can write out the null, and then I'll show you the trick right here. So go ahead and write the null hypothesis states that the true mean is equal to 85. Go ahead and write that out. Go ahead and write the null states that the true mean is equal to 85 in the chat. Who can do that right now? Just take a moment. See if you can write. Let me write it as a sentence. The null states that the true mean is equal to 85, sure, 85 on the test. Exactly. Great job, Ella, right there. Ella went and wrote mu. Now, Ella, here's the great thing if you've been practicing this. If I ask you to write an alternative, what's the only thing you'll change? And make sure to notice here that this is the true mean. And since we're testing the true mean, it'll be mu. So that's a good way. Is it mean? Then it'll be mu. Is it proportion? Then it'll be P. So mean is quantitative. And what's the only thing that changes when we do the alternative? What's the only thing that changes when we do the alternative? What's the only thing that changes when we do the alternative? The only thing that changes. The equals changes. And then we'll change it to say, like, we want to see if there's evidence. So all we're going to do right here to see if there's evidence it is not true is we can test with the does not equal sign. We could see if it's greater than or less than, but maybe someone says, I want to see if this is not the case. And then we just go right here and we have the does not equal sign. So really good practice right here. Great job, Shivam, Lauren, Ella, and Nikki, and Samantha. Excellent practice. Let's just do one more here real quick. And I want someone in the chat to give me a null hypothesis as a sentence. Like, I want to test this. Like, just tell me whatever you want to test. Like, you're going to go out and UT students and do this and see if you can give me, first off, we need to know if it's categorical or quantitative. Next, and then we just need to know hypothesized value. Hypothesized value. So let's see what people are saying. So with this information right here, let's identify. What's the difference between, so HO stands for the null states. That's the null states, and HA stands for the alternative states. The null is the starting hypothesis. 99% of people like frogs, Sarah say. Sure, that is categorical. So let's go ahead. And Sarah wants to see if it is true that 99% of people like frogs. So we're going to go right here, and we're going to test to see if the true proportion of people who like frogs is 99%. And then we should also know, so I should put in here, let's put in sign of test. And Sarah did not give any sign, so I'm going to assume that Sarah wants to see if this is not the case. So frogs right there. I like turtles. I don't know about you guys, but I like turtles. So there we go. So we have 99% of people, and we're testing this right here, and it was categorical. We have a hypothesized value, and we're seeing if it is not the case. So we go right there. Is this making some sense right here? And Kyle, great question right here. The null is the starting belief. We always have it that it is equal to this. And we have here a population parameter. P is the true proportion of people who like frogs is equal to 99%. The alternative is the true proportion of people who like frogs is not equal to 99%. Does this make sense? And do you feel like you could do this? Hopefully people are like, okay, I'm getting it. We have to know if it's quantitative or categorical right now. We need to know the sign of the way they're testing for the alternative. That sign right there will always be when we're looking at the alternative right here. And then we need to know the hypothesized value that someone wants to see tested for. So that's 0.99 technically. I should have wrote the 0.99. But ask yourself these questions right here and do it. Yes, great work. Good practice. Let's see who's going to win. These questions coming up might be super relevant to what you're about to do. Let's go ahead and take a look at these next questions. Hint, hint, hint. I tell you, everyone, leaderboard's going crazy. Silly Bee, Quick Turtle, You Can't Stop Quick Turtle, or Groovy Gecko, Fuzzy Panther. Let's find out who's going to win. True or false? Finding a relationship between X and Y proves X causes Y. I hope I selected the right answer. If I have the wrong one on this one, this is like the ultimate wrong answer. And the next 4 questions will be super important to Canvas content. A word we don't like in statistics, a word we really don't like, is proves. We don't talk about proving stuff. We talk about, do we have evidence? And will we continue to believe this? We don't prove alternatives. We don't accept the null. So no. Statistics is not about proving things. It's about finding evidence or failing to find evidence. And if you fail to find evidence, your beliefs would what? Change or stay the same. And this is the idea of what a null hypothesis is. If you don't find evidence for something, like if you hold a current belief and you go through some skeptical inquiry via a statistical hypothesis test, well, if you don't find evidence, I hope I said don't find evidence. If you don't find evidence for the alternative claim you're investigating, your beliefs would what? If you don't find evidence for the claim you're investigating, and you're right, JLo, with that, you're right. Exactly. This is kind of correlation does not prove causation, which is like more general in statistics. Like we don't like to say prove at all. We never like to say prove. If you did not find evidence for your alternative, they would stay the same. That's sometimes people call that retaining the null. We've said like 10 different ways of saying it tonight. Like I do not reject, I fail to reject, I retain the null. But does that mean the null is true? Just think about this theoretically here for a moment. Does that mean the null is true? If you don't reject the null, does that mean the null is true? It just means in this current moment, what? Like if you do not reject the null, are you saying like, I know the null is true now? No, it just means you don't have evidence against it. You just don't have, you're like, well, I still believe this is true. I mean, maybe one day later we fail to reject it. Exactly. Like I don't have evidence to go against this right now. It's my best guess, my best understanding. Like this is my current understanding. And that's how science works, is it constantly updates and looks for new evidence. I mean, you think about Isaac Newton with his apple falling, and you get Newtonian gravity, and then and then Einstein comes along and makes general relativity. So people are always improving. There's no evidence to go against it. Exactly, Nikki. Which doesn't mean the null is true. The null is just your best, like your best guess. Great way of putting it right there, Lauren. Like, this is what I currently believe, and that's what fail to reject means. We're not saying it's true. We're saying I still believe this. So I think it's fine to say I still believe the null is possible, or like the null is my current understanding. Ooh, glad goose. You'll be glad when you win this game. You can make it happen. Social zebra. Galloping away, though. Let's see. Very important Canvas content questions coming up right here. Not to go away. When creating the sampling distribution of the sample mean, what does not change? What does not change? Let's pray Brian selected the right answer. Now, there's only two possible answers on here. The sampling distribution of the sample mean is based off the sample size. You can get z-scores from it, but those are not the answers. The sampling distribution of the sample mean is going to have the same this as the original distribution. This will not change, and we'll look at the formulas here in a second. I'm not blocking any right answers right now. Don't select these answers. The sampling distribution of the sample mean will have the same mean. Great job. Great answers over there. So this is the formula right here, if you know the formulas, which you don't have to memorize the formulas, but it directly answers this question, that the sampling distribution of the sample mean, that's the mean for the distribution of the sample mean, is equal to the mean. So that's when we say it does not change. The distribution, or the mean for the distribution of the sample mean, is equal to the mean. But the standard deviation for the distribution of the sample mean gets water. Hints for later questions. The standard deviation for the distribution of the sample mean gets water. I'm about to drop major hints for some remaining questions right now. The standard deviation for the distribution of the sample mean gets water. The standard deviation for the distribution of the sample mean gets water. Tighter, exactly. This, according to the central limit theorem, hints state that the distribution will get more normal and tighter. And this is the getting tighter part of it right here, because we're dividing by the square root of n. So when you divide by the square root of n, increasing n will make the distribution tighter. This will decrease that value up there because you're dividing by the square root of n. So yeah, just mathematically, that value, that standard deviation value on the left side of the equation, I can't reach over there, it's off screen, will get smaller and smaller as the sample size gets larger and larger. And of course, we will get a normal distribution, which is not what we will use when making confidence rolls for the mean. We'll use the t-distribution for that. This is a crazy game, everyone. Crazy, crazy, mixed up game. Let's find out who's going to win. Will it be Witty Owl? I'd like to see that happen, Witty Owl. You got this. Top 3, 20, 10, and 5. Let's see who wins. When doing a confidence interval for the mean, which we use the following distribution, a confidence interval for the mean. We do not know sigma here. Not silly B. One of my favorite sayings is sigma z S and T. Sigma z S and T, and we do not know sigma. We used to, in another class, make the other confidence intervals with sigma z, but our class is S and T, which means when you're using only the sample standard deviation, you will use t-scores over there. So this goes to the formula right here. The formula, and you'll notice some similarities right here. The formula for the confidence interval for the mean is the sample mean plus or minus a t-statistic. What does that star mean again? Someone in chat, tell us what that star means. Sure, we'll put that in a different color. Thank you, Microsoft Word. Oh, we don't even have a black pen on here. I am going to reinstall Microsoft Word tonight. And I'm going to reset the router, and we'll see if we have problems this week. Aha. What does the star mean for this right here? The star means, what does it mean? Relevant to the confidence, exactly. Like, it's relevant to a certain confidence level, and here are the degrees of freedom we talked about earlier. The n-1 is how many degrees of freedom, which tell you which t you are using. So the t distribution is how we make confidence rolls for the true mean. And what is our best guess of the true mean, the what mean? What is the best guess of the true mean? Great job, Lauren and Sarah. So what does the confidence interval for the true mean is made using the what as an estimate, the sample mean. Now, what if I told you this right here, this confidence interval, which is something we'll be covering start of next week, I think. This confidence interval is made from the sample difference between two means. And what do you think? What do you think this confidence interval from the sample difference of two means is trying to estimate? This confidence interval from the sample difference between two means is trying to estimate what? This confidence interval from the sample difference of two means is trying to estimate what? So this confidence interval right here, made from the sample difference between two means, and there's the margin of error for it. Here's the margin of error for this one. Kind of. Well, this one up here up top is made from the sample mean and tries to estimate the true mean. This one here is made from the sample difference between two means and is trying to estimate the what? Well, not correlation. Good guesses there, Sarah. Good. Let's throw out some 50 points. So this one here, listen to this key right here and watch this. This will give it away, I hope. This one is made from the sample proportion to estimate the true proportion. So this confidence interval right here is made from the sample proportion to estimate the true proportion. So this is sample proportion to estimate true proportion, sample mean to estimate true mean. And so what would this one right here? So this is sample mean to estimate true mean, sample proportion to estimate true proportion, sample difference to estimate what? And this goes to the theory of confidence intervals. True difference, exactly, Lauren. True difference. Yeah, it's trying to figure out the true difference between two means. Imagine we take we take Stat 1 students from UT and Stat 1 students from Florida, and we don't see which of them does better on a test. So we give them a statistics test to see who's better, UT students or Florida students. I mean, we don't need to ask this because we know the answer. Come on, we're UT. So sorry, Florida. We are UT though. So I mean, we got you there. And so some Florida students watching this, probably not. But with this right here, we would have here two means, the mean for UT students, the mean for Florida students. And this is trying to estimate the true difference in scores for Stat 1 students at UT and Stat 1 students at Florida. Does that make sense? What this is trying to estimate right here via the notation, the mean for UT students mean 1, the mean for Florida students mean 2, the standard deviation for UT students, the standard deviation for Florida students, the sample size for UT students, the sample size for Florida students, the T statistic, which we should put a star on that on all these to tell us we are going to pick the level of confidence we are using to make these intervals. So here's just kind of a big review of confidence intervals, and at least the ones we've covered in this class, where we have up top a confidence interval for the true mean from the sample mean, a confidence interval for the true difference from the sample difference, and a confidence interval for the true proportion from the sample proportion. Big review right here, so check it out and write these down or pause the video. Let's hop back into it. Who's winning? Social Zebra, ooh, great job. Let's find out, can Social Zebra hang on? Let's find out. True or false? We can use bar charts to check the nearly normal condition. Bar charts, nearly normal. We're going back to one of the first questions right here. Nearly normal is used to see if the quantitative hint distribution can be described as nearly normal, especially when we talk about distribution of the sample mean. And the answer is most definitely false. Why? The nearly normal condition only relates to what kind of data? The nearly normal condition only relates to what kind of data? Everyone in the chat, be answering that while I go grab something right here. The nearly normal condition only relates to what kind of data? Class is not over right now. Everyone just left, though. The nearly normal condition only relates to what kind of data? Oh, am I not finding it? I swear I had it. The nearly normal condition only relates to this kind of data. Here we are. The nearly normal condition only relates to this kind of data. There we go, I got it. Let's go see what the chat's saying. Quantitative, exactly, quantitative. For this, great job, Sarah, right there. We can use histograms. We can use we can use histograms. We can use the goodness of fit test. We can use the normal quantile plot. Histograms, goodness of fit test, normal quantile plot. So here's a review of the conditions right here. Condition 1, random. Condition 2, less than 10% of the population is sampled. Then we pause and we ask, what kind of data are we dealing with? You should make a background that says intermission to use. I should, Sarah. You know what? I should make that. I can make that. I can make some cool graphic. It could be like some wavy water or something. And yeah, I should definitely do that. I always have the classes over, but it'd be really easy. There's a button I don't use. I have an extra credit button, but I just give out extra credit so much and I never use that button. So that button, it's going to go away. There's a lot of buttons I don't use, like this one.
It's not the question you deserve. It's the one you need.
I should hit these buttons more often. I've got a lot of buttons that I don't hit. You never get to see these things right here. Sad times. Sad times. Anyways, so these are the conditions right here. Wavy water. I know we should do that. We'll make it happen. I appreciate everybody. If you ever have ideas, just tell me them. Sometimes I have time to make them. Sometimes I don't. Let's see who's winning though. Oh my gosh. Exactly. Yeah, we should do something calming right there. I think so. I could put on some music. I could do that. I could take some nice music and just overlay it to a nice background. That'd be a really good idea. I like that. And so this is anyone's game. Social Zebra gets this wrong, and it's game over for Social Zebra. Social Zebra, sorry, I'm not rooting against Social Zebra. I promise. You probably at least have, like, it's Glad Goose. It's pretty much the only one who can take down Social Zebra. Silly B, though, you got a shot. Everyone else got a shot. Who knows? This is a close game. Let's find out who's going to win with the last question. According to the central limit theorem, what happens to the distribution of the mean as n increases? My gosh, I hope I selected some right answers here. This is definitely not calming music, right, Madison? Let's find out. According to the central limit theorem, what happens to the distribution of the mean as n increases? We reviewed this earlier. There should be 2 right answers. Past Brian from 40 minutes ago, you better have selected both right answers here. Because just a second ago, I'm giving out 200 points. Thank you so much, everyone who was listening in. And I like how it's even a split between those. Thank you so much. That is awesome to see to end on this. We're going to have Tiny Brian come out here and do the awards. I mean, we never get to see him so much. He's probably mad at us right here.
I'm not mad, everyone. Brian doesn't like me as much this semester. I'm Tiny Brian. So let's see who won. Remember to email Brian. Let's do this. Here we go. Third place is gonna be Silly Bay. Silly Bay. Second place, Glad Goose. Oh my gosh, you guys know who it's gonna be. Always leading the way this game. It's Social Zebra. Make sure to email Brian. I'm gonna go away.
Okay, we're back. Great job. Amazing work, everybody. If you want to say hey, who you were in the chat, amazing job, everybody. Great job. Really great Kahoot. Any questions right now? What do people think? Oh my gosh. Okay, just end the Kahoot like that instantaneously. I love listening to that music. That music's just chill. Let's put on some music right here. Do I have this button? What? Your socials, great job, Ella. I'm sharing my car. We gotta put on 80s music. We can't listen to that music there. We gotta go here to 80s music. You were Glad Goose. Great job. Amazing work, everybody. Just get in my DeLorean. Silly B. Nice job, Nikki. Wow, I'm really glad how everybody, wait, there was music all the time. There's sometimes music. It all depends. Sometimes music. What? Here we go. Just chill stream right here. Don't drive on the, supposed to drive on the street. Any question? Oh, you guys can't hear the music? Oh my gosh. You guys can't hear this either then. Wow. No. I'm going 1 mile per hour. I wish I could get the wheels to roll as I roll the car. Now you can hear the music. I was totally jamming out by myself. No one mentioned you couldn't hear the music, and I had the music turned off because I was doing some recordings and didn't want to have the music on in the background. Because when I'm doing recordings, if like I have notifications on my computer, like sometimes during class you might hear like an email notification come in or like a LinkedIn or something, and you hear like bling, bling. Wow. Oh man, I'm sorry. The music adds so much to the Kahoot. I hope I brought something to it. I like everyone's like, wait, music, Brian? There's been no do it, Chancellor Palpatine. I am sorry. I am sorry, everybody. Look at that UT Marvel right there. Go to our 80s background. Some pure 80s right there. And my thing, I switched over to the other streaming thing and the background worked consistently, but it didn't seem to fix any of our streaming issues. And I don't have everything set up on that. What other questions are there? We'll put on some 80s serious music. What other questions? How is everyone doing? We'll finish up here. I think we're gonna probably play 320 later this week. Did I put three? Do we have 320 here? I don't know if we have. Who is all here? 320 is working on their assignment probably. Any last questions? But no, thank you everybody. Really good practice tonight. Get ready for more Kahoots. Get ready for more review. We'll be doing project streams this week. So if you have questions about the project, please let us know. I'm able to send my project to you. Yay! I'm able to send my project to you. Check it over for you. I do a quick review of it, Cody. Or Kyle, sorry. Cody was right above you right there. So I do a quick review of it. I look at the graphics. So I don't read every sentence, but I look at your graphics. And so this project has more parts to it, which is a good thing. Yeah, let's do some null review. Let's do some null hypothesis review. You got it right there. Let's do it. And you want to do over the sign? You're welcome, Parker. Head over to here. What do you think about that puppet shark? Little puppet shark, tiny puppet shark. Project 2 videos. Let me put those in the playlist, or let me put those in the link. I sent out a link to the class with Project 2 videos. I sent out a lot of links. I wonder, am I your teacher who sends out the most links? I don't know if that's a good or bad thing. Like if I am, it might be. 80s music. Okay, here we go. Project 2 playlist. Oh, thank you so much, Ella. Glad to hear that. I generally, if you have a specific question, none of my teachers send links. If you have a specific question, let me know. Like if you're like, hey Brian, this one I'm stuck on, let me know. It's hard for me to grade a whole project. I have a lot of students. This one has a lot more graphics on it. If you're wondering about a specific part, Kyle, then email me about that specific part. Be like, hey Brian, did I interpret my confidence roll correctly? Or hey Brian, did I do my conditions correctly for the confidence roll? And really, the visualizations can be a good guide for this too. So if you're wondering about a specific part, ask me about those specific parts, because I've already reviewed maybe 24 projects and quite a lot already. So great job, everyone, already getting started. And like if I review a whole project, it would take me like 5 minutes. I know you're like 5 minutes. Come on, man. But that would already be 2-3 hours of like just project review, and I have 700 students, so I will review it very quickly and I will answer direct questions about this. Does that make sense? I hope everyone's good with that. I'll like give a quick glance. I'll be like, everything looks good here. Usually, unless I see something major, like I don't think I've ever reviewed a project and someone's gone below an 80. Usually they get like 90s or above, but that doesn't mean you will, because I might miss something, but I try to look quickly. Let's hear Cody asks, can you go over, please do like a review over the null signs. So the null always has the what? 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 Note to self, reinstall Microsoft Word after this. We had a stats teacher come by from another class, Cincinnati Stats, and he said he liked the way I teach this. You might see me do this, especially when we're reviewing. This is your general format for the null and alternative. So with this right here, you've got how the null and alternative are generally formatted. So the null always has the what? What are we highlighting right here? What are we always highlighting right here? The null always has this. The null always has this. Like, you have to know this. This is what makes writing the null very easy. The null always has this. The null always has this. It always, 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 always has this. What's the null always have? Whenever you're doing in statistical notation, we'll always give the null the what sign. What will the null always have? The equals. Great job, Cody. And then here's where we put a population parameter. So we'll put a population parameter right here, which will either put P, mu, or mu1 minus mu2. Okay, I did it. And let me vanish. So down here we'll go P, or mu1 minus mu2. So these are the possibilities. And then here just goes a value that we're testing, but it's the same value. How is the alternative decided? The alternative we decide on will be based on what? The alternative we decide on will be based on what? How do we decide the alternative for this? How do we decide the alternative? It'll be by how the question asks. So when the question says we want to see if students' grades have been increasing, we would choose the increasing, the greater than. If we want to see if for some reason perfect attendance has changed, we would choose the does not equal sign, because either it's the same or it's not the same. It's changed. This value over here is going to be the same. I want to point something out. Whatever you put for this field right here must go in the same. These are some big things to note. Whatever you put right here goes right here. Whatever you put right here goes right here. Does that make sense? So if you know how to write the null, the only thing you change is the what when writing the alternative. So Cody, if you know how to write the null, and then we'll do a practice on this. You've got your cheat sheet right here for all statistical ways we write nulls and alternatives. If you know how to write the null, the only thing you change is the what. If you know how to write the null, the only thing you'll change is the what. If you remember, we were finding the hypothesized value earlier. Is the value we're testing, saying, is this equal to this? The sign. Great job, Cody. So let's do a problem right here. UT knows in past years that the proportion of in-state students is 67%. Yeah. They want to know if it has changed this year. What is their null and alternative? So with this right here, let's put it all on one screen. So go ahead and see if you can solve this. So what will this be right here? And you are correct, Cody, it will be the sign's the only thing that changes. So see if you can solve this example problem. Write out the null right now. See if you can write the null hypothesis. And look for keywords to help out with what the things you are looking for are. So write out the null hypothesis right here. What will be the null hypothesis? And this is the practice right here. Can you write the null hypothesis? Remember to write everything. The null states that the something something is equal to, and you'll use one of these values right here. So what would the null be? How would they state the null hypothesis? Just practice right here to write the null and alternative. Great job. Yep. Great job, Cody. You got it. Great job, Cody. And then what's going to be the alternative? What's going to be the alternative? Because now all you have to do is change one thing. Once you write the null, you just change one thing. A lot of people start changing a whole bunch. They start changing the value. They start changing the population parameter. And it's like, no. Just change the sign. That's all you change. Everything else stays the same. Once you got the null, just change the sign for what you're looking for evidence of. They want to know if it's changed. So their question is, it was this last, historically it's been this. Is there evidence it's changed from the current sample of students we have? Is there evidence it has changed from the historic number? And so what would be the alternative? You got it. Is it making sense, Cody? I'll do one more difficult one. Maybe I'll try to make it more difficult by not saying exactly what it is. Here's going to be a tougher one. You ready? If you get this, you're doing great. So spell things out if you don't have the symbols for them. Hints for this. This is a tough one. We haven't even done this chapter yet. That's a hint. That's a huge hint. Just read through it and just think about what we're testing right here. And ask questions if you have it. So, what are you noticing right here? We're testing what? Just kind of think about how to explain it and what down here in the words and stuff makes sense. Definitely a tougher one. This is about tough as I can ask right now, or at least with what we're currently at. But I think if you look through the options, you might see one that jumps out to you. You might be like, oh, well, it kind of sounds like we're talking about this. And then you have to ask, what's this going to be? Just think about since nothing's given. If you get this one, you are way on track. You're beyond on track. We won't use the greater than sign. So no preference is given right here. UT in Florida wants to see which students are stronger. We never give a sign, so we're going to use the does not equals because we never give a preference. That's a really good question right there, because if the question doesn't say what we're looking for, you assume it's just a difference. So we've narrowed it down to this. We know the null has the equal sign. So what else can we narrow down right now? Especially think about it. I think this one might be the easier one to figure out. Like what will go in this blank? What are we testing right here? The what right here. And that'll... So you got three options. Option 1, option 2, option 3. The proportion, we're testing the true proportion, the true mean, or the true difference between two means. Yep, U1 minus mu2. And we're testing two groups right here, like two means. Yep. No value is given, so Cody, take a wild guess at this. Take a wild guess at what value we would test, since we're just saying, well, we're going to test to see if there's a difference. The null would assume that there's what difference between the means? That the difference between the two means is what? If we're testing to see if there's a difference, and the null is that there's no difference, the value we would use to test is what? And this is usually what it is when we test two means by default. The value is 0. Does that make sense, Cody, right there? I might just play the same song. So this reads, the null states that the true difference between UT and Florida students is equal to 0. The alternative states that the true difference between UT and Florida students is not equal to 0. So this would say that there is a difference. This can also kind of be quickly written out. Some people will write this as, if you mathematically move it around, you can say mu1 equals mu2, and the alternative states mu1 not equal mu2. It wouldn't follow the same format then, but it kind of makes more sense when you read it to say the null is that, yeah, exactly. And that's usually for the true difference, because mathematically, if you move this over, you'd just be saying the first mean is equal to the second mean, the first mean is not equal to the second mean, which is saying that they have no difference, because if they're equal to each other, they have no difference. So this is a chapter we have not covered. I think we'll be starting it. I don't know if we'll start at the end of this week, because I want to finish up some testing, and then we'll go into the next chapter. We go right up until the end. Every class is useful. Every class is important. Lots of topics, lots of review questions. But great job, Cody. Is it making more sense? That was chapter 17. That was, which we haven't published yet. I'm finishing chapter 16. That was, but that is a branch on chapter 15. So Leslie, if that looked really familiar to you, that was chapter 17, but chapter 17 goes over testing and testing and confidence roles for two means. So instead of one mean, there'll be two means. So you'll be testing the difference between two groups. Great questions. If you have more questions, Leslie, let me know. We'll start ending right here. Awesome. My dad's got a new sound system. But with that, here we'll put on our UT Marvel background. You know what I should do? Maybe I can make the UT Marvel animate a little bit. I don't know. It's one of the few things I've commissioned. Wrong button. My UT Marvel button. There we go. Okay. I've already got 10 videos playing. Well, with that, everybody, we will be back. I'll see everyone tomorrow. Keep up the great work. Until then, bye for now, everyone. Bye.